Hi, and welcome back to our flipped chemistry classroom. And today we are beginning our discussion of nomenclature, or how we name chemical compounds. So we're beginning with ionic compounds, and just a quick reminder of what a chemical formula is. So a chemical formula is going to tell us the number and the kind of atoms in a compound. And so we have molecular formulas that show us the number and type of atoms in the molecule, and that's when we have covalent bonds. Then we also have formula units that show the ratio of the ions in the crystal lattice. And so we're going to learn how to name the ionic compounds first. And we're going to start with ones called type 1. So our type 1 metals are those metals that have a fixed ionic charge. So that's groups 1 and 2 and 3. So that's the alkali metals. And we know that when the alkali metals form ions, they always have a +1 charge. We have the alkaline earth metals that we know when they form ions, they always have a +2 charge. And then we have the boron family that always has a +3 charge. And then there are 3 sort of transition metals that also always have a fixed ionic charge. And those are silver, zinc, and aluminum. And if you look at a periodic table, they make a little diagonal line beginning with silver through zinc through aluminum. So silver always has a charge of +1, zinc always has a charge of +2, and aluminum always has a charge of +3. So these are the type 1 metals, and we're going to learn how to name ionic compounds that contain type 1 metals. So we're not dealing with transition metals yet, except for silver, zinc, and aluminum. So when we name these, first we name the cation, and we remember that the cation just has the name of the element. So the calcium cation is just called calcium. And then we name the anion, and we change the name on the anion. We take the root of the element name, we take off the ending, and we add IDE. So chlorine becomes chloride. So when we're naming this compound, it's calcium chloride. And we don't have to say anything about the subscripts because we know what the subscripts are because the charges tell us how many of each we need, because our compounds are always neutral. So we're going to practice naming these compounds. So we have first Na2S. So we're going to name the cation, that's sodium. And then we're going to name the anion. And because this is sulfur, we're going to drop the ending and add IDE. So this becomes sulfide. So this is sodium sulfide. For the second one, we're going to name the metal, the cation, aluminum, and then we're going to name the anion, changing its ending to "ide," so it becomes oxide. So this is aluminum oxide. For our third one, we have zinc, and then we have bromine. So we change it from bromine to bromide. So we have zinc bromide. And then we have calcium oxide. We have potassium nitride, we have boron chloride, we have strontium iodide, cesium oxide, and calcium phosphide. So notice that as I named those, I did not use any prefixes. We don't need to say in the name of an ionic compound how many of each thing we have, because that is determined by the ionic charge. And we know that the ionic compound has to have a total charge of 0. So we know that we have to have 2 sodiums to go with 1 sulfide, because these are each +1 and this is -2. So we don't have to say the numbers in the name. And there are the answers. And so now we know how to name them. How do we go from name to formula? So when we go from name to formula, we want to make sure we write the cation symbol first and then the anion symbol. Then we're going to use the periodic table to determine the charges of the ions. So if I were given the compound barium nitride, I'm going to look at the periodic table and I'm going to see that barium is in group 2, so I know it's a +2 ion. Then I'll see that nitride is in group 5 or group 15, so I know that it's going to be a -3 ion. So I know that I have a +2 and a -3, so I know I'm going to need some subscripts because these two right now don't add up to 0. So I'm going to use the subscripts to show how many of each atom are needed to make the compound neutral. So I need 3 barium ions to have a total charge of +6 and 2 nitride ions to have a total charge of -6, so that my +6 and my -6 add to 0. And I'm going to write Ba subscript 3, N subscript 2. And once again, we're going to practice. So we have sodium chloride. So I know that sodium is a +1, chloride is a -1. So I need 1 of each. So I'm going to write NaCl. And calcium sulfide, I know that calcium is a +2, sulfide is a -2. So again, I just need 1 of each. So I'm going to write CaS. With barium fluoride, I know that barium is a +2, fluoride is a -1, so I need a subscript 2 on my fluoride ion, so BAF subscript 2. With silver nitride, I know that silver is a +1, nitride is a -3, so I'm going to write Ag subscript 3, N. With zinc oxide, I know that zinc is a +2, oxygen is a -2, so they don't need any subscripts. With potassium sulfide, I know that potassium's a +1, sulfide's a -2. So I'm going to write K2S. And with sodium phosphide, I know that sodium is a +1, phosphide is a -3. So I'm going to write Na3P. And there are answers. And as always, I'll post the slides for you guys to take a look at. If you have any questions, let me know. And I look forward to seeing you in class.